Inshallah, today we will continue with chapter 3, and today we will move on to chapter 3.3. In the previous lecture, we have done chapter memory management, chapter 3.2, and inshallah, today we will continue with chapter 3.3. So, basically, what chapter 3.3 is going to talk about is input output management. How does the computer and the operating system handle all the inputs and outputs towards the computer, and how does the operating system help to make this uh, better managed? Okay, so inshallah today we will just finish up. We'll try to finish up 3.3. Okay, before that, let me just recap what we have done in 3.2. In chapter 3.2, we have understood about the memory management. We have looked into paging, segmentation, virtual memory, first in, first fit, best fit, worst fit, and how does the operating system manage large processors. So, as we have known, processes are broken down into several pages, and we looked also into page table, how each process is broken into several pages, and how does the CPU get access of each page in the physical memory, and also the secondary memory. In segmentation, we also understood that each process is broken down into several segments, and so on, and we also looked into that, and we also understood what is virtual memory. So just remember, virtual memory is a location inside your hard disk. However, virtual memory only appears if and only if your physical memory, which is your RAM or your main memory, which is full. Once it is full, then the operating system will automatically get a portion of your hard disk and convert that into virtual memory. So that virtual memory is actually belongs to your main memory or your RAM. Okay, so today let us just continue with input output management. So basically, two main jobs of the computer is to handle input outputs and to do processing, meaning the computer will get all the inputs and all the outputs by the devices and do some processing. For example, let's say you have installed your laptop or your desktop, your PC with a printer. So once the CPU processes the data to be printed, it will release this data into the printer. So the printer is known as the output device for the computer. So what is the job of this operating system? The operating system makes sure that all of this is done in a proper manner. Another input or output you can consider input is the keyboard. The keyboard is also considered as an input to the computer. So once you type in certain informations on your keyboard, this information is actually processed by the computer, by the CPU, and this information will reappear in the output device, which is the monitor. So there is a what do you see? There is a correlation. There is a continuation between the input from the keyboard and its output on the monitor. Okay, so next we go to the role of the operating system in this uh, CPU is to manage and control the input output. So it will manage which input is needed first or which input should be done first, and where is this input coming from. So that's the input devices. So how does the operating system manage this? It will look into three different categories. One, it will look at the number of data which is coming in, different amounts of data, and at what speed is coming in, and in what format it's coming. Is it coming in the form of character? Is it coming in the form of bytes? Is it coming in the form of pictures, and so on and so forth? So that's also looked into. So, for example, if you're looking at speeds, for example, if you type something on your computer, that's very fast. On your keyboard, that's very fast. So the speed is very fast. So the operating system needs to help the CPU process this information at a very fast speed, because when you type A on your keyboard, you want A to appear on your monitor, not that you type A, B, C, and it takes about 10 seconds later only it appears. If that happens, that means something is wrong with your computer and the operating system is not helping at all. And sometimes we have different types of data coming in. For example, keyboard sends a different kind of data. It sends characters. Sometimes when you scan information, so this information comes in a different format and a different type of data. So the operating system will handle what kind of data which comes in at what speed and what format. Next, we look at the speed, how fast or how slow. So the operating system and the CPU will look into this matter. So if the input is coming at a very fast speed, so the operating system needs to handle this, and it will coordinate well with all other input and outputs, which input should come first, which input should come later, and so on and so forth. These are examples of input and output devices in your computer. So you have the smallest as the keyboard, the mouse. The mouse is also considered as an input because you click something here and it appears something on your screen. So that's also an input. So voice input, like how I'm talking now. Okay, this is a voice input to the computer. Okay, and you have an output. Voice also can become an output because speaker is also an output, and the inkjet printer, laser printer, these are all outputs. And the optical disc, sometimes your hard disk, these are also considered as input and output, because sometimes you want information from your hard disk, sometimes you want to store information inside your hard disk, so these are also considered as input output. And sometimes these are storage, and so on and so forth. So each type of input and output devices come in a different types. Okay, some come in the character, some come in block means one chunk after another. Like say for example, I'm talking now, hello, how are you? So the sound is transmitted to the CPU, to the computer, based on blocks. That means hello is one block, how is one block, you is one block. It's not alphabet by alphabet, but it's blocks by blocks. And this will be processed inside the CPU and will reappear or restore, and will be stored in or whatever lah. Okay. For example, also keyboard. Keyboard comes in character by character. Okay. So each character you type in will be automatically sent over inside the CPU. Okay, so how does this configuration work? Okay, on the left hand side here you have the CPU, which is where all the processes will take place, and you have the input output module and the input output device. Each input output device will share one uh, IO or input output module. Okay, I repeat now. Each input output device will share one input output module. For example, like the USB. So you might have in your laptop or your PC 5 USB. That does not make it 5 input output module, because USB are all the same and it's all connected into one. So you will have one IO module, input output module for all the USBs. However, it's different for the graphic card. Graphic card handles only the screen display and monitor display, so that you will only have one input output device, one input output module for the graphic card. So all of this input output device is connected to the module and is also connected to the CPU. So the CPU will process this and then send it over back to the input output module, and this input output module will then send it to the input output device. Okay, sometimes you can have even your modem is also considered as an input output device, because the modem gets the connection from Uni5 or wherever you are, and delivers it to the input output module, and is also then delivered inside your PC to the CPU. So generally, how does it work? CPU checks the input output module for device status, meaning this happens when you on your PC, on your laptop. When you on your laptop, the CPU will automatically check each and every input output device. If you notice, if you have a desktop, when you during the process of booting, you will see each of your input output blinking once or twice. So when it's blinking once or twice, the CPU or the operating system is actually checking if this input output is actually working, if there's any error. If there's any error, then a special blinking sound, sorry, a special beep sound will appear. Okay. However, once the PC is on, like now, the CPU will continuously check in each input output module to see if there is any input, or if there is any error message, or if this input output is ready. Okay, so it will continuously do this in a rotation basis. And the input output module will send the status. That means if the status is free, or the status is processing, or so on and so forth. If busy, need to wait for input output device. If it's busy, meaning that means it's doing something. What do you mean by it's doing something? Probably it's waiting for an input to come in. Okay, input come in from, it could be anywhere. Or if it's ready, meaning it's free and it's waiting for any data to be transferred. Okay, it's waiting, it's free, it's waiting for the data to be transferred. For example, the input output module for printer, it's always ready. It's just waiting for any data to be put it inside it and for it to run the process. So, and the input output module transfers data to the CPU continuously. Okay, continuously it will transfer data to the CPU. Okay, what is input output module as per se? Responsible for control of one or more external devices. That's why I said if you have 5 USB, it does not make you have 5 input output module. You can only have one input output module, but it's all connected to one or more devices. Okay, one or more devices. Sometimes you have one USB at the front of your PC, so you put in a thumb drive there. Sometimes you have another one behind your PC, so that maybe you put in your headset, or maybe you put in your webcam over there. So these are all three devices. So all these three devices is actually having only one input output module. And then between the input output module and the CPU, there is something which is called a CPU register. So before the input output module sends data from the input output module to the CPU, there is a uh, small location in between here, which is called the register. So the register is uh, will actually keep the data before going inside the CPU for processing. Why is that so? If you remember in the previous slide, in the previous chapters, the CPU can only process one data or one process at one time. However, because our CPU, our keyboard, our computer is running multiple processes, that's why certain process needs to be kept in the register for a short period of time. Okay, where is this register? Registers are located actually inside the CPU, but it's not being processed yet. A CPU is some sort similar, sorry, a register is part of the CPU, and it has memory and is keeping the process before it's being processed by the CPU. Okay, a CPU is a CPU RAM? No, a CPU is not RAM. It's not nothing to do with RAM, but a CPU is a small memory location dedicated to each external devices. Okay, each external devices. All right. Next, we move on to uh, sorry. Next, we move on to okay. Next, we move on to input-output module types. Okay, so once we have also have something which is called the programmed input-output. With pooling, data are exchanged between the CPU and input-output module. The CPU has direct control of the input-output operation. When the CPU issues a command to the input-output module, it must wait until the input-output process operation is complete. Okay, meaning okay, once the CPU has processed the data, it will send it back to the module. Okay, so in this diagram, the module is called as controller. It's almost is the same actually. Input output module and controller is the same. Okay, so you can see here there are different types of controllers here. For the graphic, there is one. For the USB, is connected to multiple devices, and for the disk drive or your hard disk, It only has one. Okay, so the data is sent to the disk controller and also to the CPU, to the USB controller, and to the graphic card. Why is it so? As you can see, it goes to three different outputs. For example, if you want to print something, so the data needs to come from the hard disk. Let's say you're printing Microsoft Word, so the file is inside your disk, so it goes inside to be processed. Next, you want to print it, so the CPU sends that same data to the USB controller here to be printed. Okay, to be printed, and also it sends the same data to the graphic adapter on the screen, so that there is a message on the screen saying that your document now is being printed. So it goes into three different places. I'm sure you have seen this before. When you type your Microsoft Word and you start printing, you get the print screen, okay, how many pages you want to print, and so on and so forth. Once you start printing, you also get a message, your document is being printed, okay? And all of this is stored inside the memory, okay? You must remember all of this is stored inside the memory. The process is also stored inside here, okay? But you might be confused because previously I said there are also registers. Okay, some registers, okay, will be inside the CPU. They will consider the registers are inside the CPU, but it's not part of the memory. Okay, so when the data comes in, sometimes it goes in inside the CPU, sorry, inside the register to be processed. Okay, but again, all of these are stored inside the memory. Okay, so the CPU must, once it issues a command, and you must wait until, that means it cannot continue with the next job until the first job is completed. That's what it means by pooling. Okay. Next, we also have something which is called the interrupt driven. Interrupt driven is, for example, let's say the computer is doing something or the printer is doing something, but there is an interrupt by the input output. Okay, the CPU issues a command and then continues to execute other instructions, and the input and the IO module issues an interrupt when it's complete its task. Interrupt means input output module device controller notifies the CPU when the service becomes ready for service, meaning once the printer is done. So it interrupts back the CPU and say, okay, that's why you see there's an arrow between, here. There's an arrow between USB and the arrow goes back here, or maybe the arrow goes back inside this control, meaning you have done the printing and the input output itself, the device itself sends an interrupt back saying that yes, I have done the required process. Next, we also have something which is called the direct memory access. Okay, direct memory access, if you can see here, all the inputs coming from each of the device goes inside the memory. Before it goes inside the memory, it also connects directly to the CPU. As you can see, there's also one line here. In the direct memory access, okay, direct memory access is a bit different. Okay, when large blocks of data need to be transferred between a device and main memory, the CPU sends a signal to a special chip called direct memory access controller. Okay, so what does this happen? Okay, if there is need to transfer large amount of data from the input output device before it goes into the CPU, because you have to understand each process that needs to be processed by the CPU will go through the CPU first, and then it goes inside the memory for it to be stored. However, when there is large data coming from the input output device, for example, if you're downloading large files, then the CPU will send signal to a special chipset. What is a chipset? This is kind of memory, okay? This is kind of register to send signal to the direct memory access, meaning it will not go through the CPU, but instead it will go in straight into the memory to be downloaded first inside it. Okay, download it first inside it. Okay, so sometimes you have this inside your disk drive, sound card, and graphic card. Because this, how do you know it's a direct memory process or whatnot? Okay, the direct memory access process is usually large datas, okay, and it does not actually require processing. For example, if you're listening to YouTube, okay, the sound which comes in, it does not need processing. It's just mere just listening, okay. So and then if you're watching any movies, for example, so that all, or you're just accessing a file, but that does not need processing. So when that does happen, the CPU will transfer that process straight away into the into the main memory to be to be kept inside it. Okay, so when the CPU encounters an instruction relating to input output, first, what does it mean? That means the CPU gets a process, so it's processing the particular process. So let's say you're opening Microsoft Word, so that is a process. So once you want to print, so you want to access the input output device. So there are three categories. So one is it goes into pooling. That means the normal queue. So the printer, so the CPU sends the control to the printer module, and it waits there until the printer is free, or if the printer is free, it continues and so on. Next is also interrupt driven. Maybe the printer has some problems, so the printer will send a signal back to the CPU and say that, oh, ink, there is no more ink, and so on. Or maybe if there is a large number of process, for example, let's say you want to print 100 pages, so the CPU cannot wait until the 100 pages is printed because the CPU has other things to do. So when the CPU has other things to do, that process, which is already been processed, will just be transferred into the memory, and it will continue on just from there, not from the CPU anymore. Okay, it will just run from the memory. It goes into the CPU. Let's say you are now doing Microsoft Word, you have about 200 pages to print. So once you send that signal, because there's a large amount of data and the CPU cannot wait for this, so it will send that process into the memory for it to continue printing. And the CPU, by that time, it can do anything else. Okay? Or else you will get a situation whereby you cannot do anything else until you finish 100 pages. Only then you can move on to the next process. Okay, so we have covered this. Okay, so these are all how the flow happens. The CPU checks for input output, and if it's ready, the status is ready, and if there's any error condition, and how the input output sends back signal to the CPU and memory. So interrupt driven is whereby the uh, input output device sends an interrupt or sends a signal back to the CPU to tell either it's ready or to say if there's any problem with the devices and so on. So this is the flow, and this is also direct memory access, whereby you bypass the CPU to transfer data directly between the input output device and memory. Okay, you direct the what you say, the the data transfer is just done between the input output device and memory. Okay, it's just between them only. It does not need to go through the CPU to be processed. For example, like I mentioned just now, if you're downloading a file, a big file, a movie file, or you're watching online movies, you are listening to YouTube, so that just goes through straight to the memory because it does not need to be processed. Or in a different condition, if you're doing Microsoft Word and you want to print 100 pages, so once you send the request, so that request will now be transferred into your RAM or your main memory, and it will be processed on from there. So this is how the flow is done for direct memory access. Okay, next we also have something which is called the buffering. Okay, so what is a buffering? Okay, a buffering, for example, let's just look at the example. A buffering is a memory area that stores data transferred between two devices. Two devices. Okay, look at this, two devices, or device and application. Two devices means, let's say you are transferring from USB 1 to USB 2. These are two devices. You want to copy from USB 1 to USB 2, two devices. Or you want to copy from USB to your hard disk. or you want to copy from your let's say scanner to your hard disk. So these are two devices. Or you want to copy from your device to your application, or you want to do memory transfer. For example, you scan a document, import output device, and you want to open it in the application. So that when you scan your device, when you scan your documents will appear on the screen. So these are the import output device and the application. Or, for example, you open Google Meet. Okay, so that's an application. So and then you connect it with your webcam. So that's an input output device. So once you get the picture, it appears inside your application. Okay, so you have something which is called the buffering. So let's just look at this example. A file is being received via a modem for storage on the hard disk. So you're getting a file from the modem, and this file needs to be stored inside your hard disk. So it's between the input output device and another device. Okay, so the modem is about 1000 times slower than the hard disk. So the buffer is created in the main memory to accumulate the bytes received from the modem. When the entire buffer is data is received, the buffer can be written to the disk in a single operation. Hard disk is running very fast. However, the modem is very slow. So there is a buffer in why. Okay, so there's a buffer in between. So the data comes from the modem, sits inside the buffer. Once it's being received, and then it will go into the hard disk. Okay, this usually happens when you want to download a file. Okay, it does not directly go into the hard disk. It goes inside the buffer. Once it's gotten everything, and then automatically it goes inside. Okay, so because the modem is slower than the hard disk is very fast. So the buffer will just collect everything one by one, and then once it's done, and then you put it inside your hard disk. For example, I have about 60 students. If each of my students give me one assignment one day, it's going to be 60 days. Okay, so why not I just ask a class rep, is considered a buffer, to collect everything. Once everything is done, gives it to me for me to mark the test papers or whatnot. Okay, so this is what we say as buffering. So why use buffering? Example, at the sending side, a large message is fragmented into small packets. So you can actually keep all the information in one place first before it's being transferred into your hard disk, or else you cannot do anything because it's the CPU time is being there, and then you're using too much of memory because the process is not being done because you're downloading so big of a file. So now you use buffering, at least that process is now being taken care of the buffering. So we have a few types of buffering here. One is the block, meaning it will transfer block by block. Once the full block is received, and then it will transfer that block into the hard disk. For example, you are downloading a file, so each time the file comes in, it will transfer by block by block. Once the block is done, once the block is full, downloaded, then only being transferred. Or you maybe have streaming. Okay, this is what you normally hear. Streaming is either line by line or byte by byte at a time. That means you stream the data comes in and out as a stream of bytes, not block. Block means it waits until one block is done, or one block means you can consider as one word lah. Okay, one word, and then it's transferred. Streaming means line by line. Okay, that means all the data comes into the buffer based on line by line, or you can have it byte by byte. Okay, or line by line. And then you can have a few types of buffer: singular, double, or circular. So this is a singular buffer. Okay, input output device in operating system, no buffer, and it goes into the process. Or you can have it as a single buffer. It goes in operating system's job is to keep keep the data there. Once the data is full inside the buffer, you will move on to the user process. Or you can have a singular buffer. That means you're using more than one buffer. So a process can transfer data to and from one buffer while the operating system empties another buffer. Meaning, device comes in, it goes into first, let's say this buffer, and it's being collected. and then it's being transferred here, and at the same time, once this process here is being done, it moves back here and it goes to a different buffer and it goes out back here. So at the same time, you can consider one buffer is getting and one buffer is getting the input, one buffer is releasing the information or input. Okay, so you have a double, or what we say is a singular buffer. So that means it will continuously. That means one buffer will get the information, process. Another one will get the information, but go on this side. Okay, it will go back to the input output. Okay, again circular. Okay, it continuously moves. Okay, all right, so that's all for chapter 3.3. So what have we covered in chapter 3.3? We have covered chapter 3.3. Let's just go back in on a fast pace. We have covered what is input output module. So input output module is something in between or handles all the devices in the CPU, and each device will have at least one input output module. Some people call input output module as a driver, also acceptable. You can consider input output module as the driver, and then how are these data being transferred through pooling, interrupt driven, or direct memory access. Next, we also have covered what is buffering. So you need to understand why do you use buffer, because the speed is matched. Okay, the data which comes in is slower than the data inside, so we need a buffer. So we also have what kind of transfer rates. We have a block-oriented buffer, streamline, okay, buffer, and we have three types of buffering, which is the singular buffer, double buffer, and the circular buffer. Right. So the operating system's job in this chapter is actually to keep track of all information which comes in, one, inside buffering, and two, when it comes in inside through the input output module. All right. So I hope you have you have understood what we have done today. And again, if you have any questions, please write your questions in the comment section in this YouTube. And I hope you all click like, and I hope to see some questions. So if you have any questions, please type in there, and I'll try to answer it as immediate as possible. Thank you very much. Assalamualaikum warahmatullahi taala wabarakatuh.